Hello, my name is Andrew Kallai and I'm an undergraduate student at the University of Delaware. This presentation is about the OpenMP Validation and Verification Test Suite. The OpenMP Validation and Verification Test Suite is also called the OpenMP VMV. It was formerly called the Sol VMV under the duration of the Exascale Computing Project. Collaborators to the VMV include members of the University of Delaware's Computational Research and Programming Lab, and also members of Oak Ridge National Laboratory. You can visit the project website at crpo.cis.udel.edu/ompvv to learn more. This work is supported under the S4PST project in conjunction with the U.S. Department of Energy. External collaborators to the VMV include members of the industry from AMD and Siemens, as well as former members of the University of Delaware. Objectives for the VMV include, in general, testing implementations of new features introduced in OpenMP API specifications. These specification features range from 4.5 to the newest 6.0. We check conformance for existing implementations in implementing these specification features. This is a peer-reviewed process that is publicly available. In the process, we highlight ambiguities in the OpenMP specification, which allows for improving language in the specifications, and in addition, reporting the status of implementations for given features of the OpenMP API. This helps application and compiler developers who in general write these features to target given platforms. We run the test suite on primary supercomputing target platforms in conjunction with writing tests for given abstract application kernels. This is done in order to prioritize certain use cases for OpenMP. The latest OpenMP specification version is 6.0. This was introduced as TR13 and released on August 2024. New features have been added in this version, as well as deprecation of old features, removal of deprecated features, and behavior changes to existing features. Some of the new features in the specification have been implemented in open source compilers. The status of these implementations are available at their respective links. Because there is lacking implementations, it is difficult to test the features that have been introduced. In general, the 6.0 specification is expected to be released in November of 2024. You can clone the VMV at the respective GitHub link. One can load a given compiler and use the makefile provided to run the entire test suite. By specifying a sources, as in the example, one can test a singular test. For running the entire test suite, only specifying the OMP version is required. For running using multiple threads, one can specify a jobs number to make. We measure test coverage by counting tests written for each of the three languages, which is C, C++, and Fortran, that is supported by OpenMP. Coverage is highest for 4.5, as this is the oldest version, but in general, coverage is steady throughout the respective versions until the latest which is 6.0. We prioritized new features for testing. These are features which have common usage scenarios or certain requested features. In general, we are adding new 6.0 tests to cover the latest features, but we do add a test related to any given version to achieve, in general, coverage for given usage scenarios. We then run the test on given systems, which include Perlmutter, Frontier, and Sunspot. This is done to test each of the listed implementations against given application environments, which have various different types of GPUs, including Intel, AMD, and NVIDIA GPUs. With our results page, we are able to display our monthly Testsuite runs. A user can access a given compiler or given system to filter down results. By looking individually at each test, a user is able to see if a given test passes or fails based off of runtime or compile time errors. We count the passes and fails for each of the implementations and display them in this graphic. In general, the higher the bar chart, the larger coverage there is for the given implementation. LLVM has relatively low coverage for Fortran due to ongoing development with Flang Nu. In general, 4.5 coverage is the largest, but this trend does not hold for all versions, as you can see. 5.0 coverage is still relatively large. 5.1 coverage is noticeably less due to lacking coverage for certain implementations. 5.2 has less coverage, and it is also notable that 5.2 has less tests available for checking coverage. However, there is still relatively good coverage by certain implementations. 6.0 is not displayed here because coverage does not exist in the test suite that well, as implementations have not been made yet. But we continue to write tests on a usage case basis, which includes checking given features of interest from the specification. These features range from fusion of loops to using device or host addresses on the device or vice versa with the host, as well as checking assume-sized arrays and various loop-changing constructs. We add new features on a regular basis. The additional work displayed here is a continuous integration benchmarking suite, which displays results for tests that pass and fail on a regular basis at the University of Oregon's system. Members of the University of Delaware have also implemented this CI for the Hackbench as well as AMD smoke tests. Our repository is accessible on GitHub. One can view the various issues and pull requests that are ongoing, as well as the wiki pages, which give information on how to contribute. We welcome new contributors and advise to view our website for more information or reach out to me or any other current members to help contribute. Thank you for listening to this presentation.